All right, so this video is going to be about the incenter, which is at the intersection of the angle bisectors of a triangle. So we already talked about medians, which are at the intersection of the bisector of a triangle. So if we bisect a line, right, or a segment, we get a bisector, or a median if we draw from that midpoint to that vertex. What we're going to talk about now is finding the angle bisector, so looking at the angles and cutting those angles in half and then drawing a line. Notice where we draw that line might not be in the middle of these segments. So what we need to do is find what the angle measure of these angles are. So this one right here looks to be about 60 degrees. So if I cut that in half, it'll be at 30 degrees, which is right here. And I'm going to connect that dot to this vertex in order to create an angle bisector. So this line right here bisects this angle into two equal pieces. So that's our first angle bisector. Our next angle bisector will be the bisector of this vertex right here. So if I find that angle measure, if I put it on there, it looks like the angle measure here is about 80 degrees, so that'll be about 40 if I bisect it. So I'm going to put a dot there at 40 and connect that to my vertex. And this line right here cuts this guy in half into two equal pieces. It bisects it. So there's another angle bisector. You can see where they intersect. And if I draw my last angle bisector by measuring this angle, let's turn the page. If we measure this angle, it looks like it's about 40 as well, so 20 will be about in the middle. So I'll do 20 here, and that should cut this guy in half as well. So he's cut into two equal pieces. So the angle bisectors all intersect at a point, or at least they do when you're careful. And we call that point the incenter. And the reason we call it the incenter is because that point right there will produce a circle inside the triangle where this is its center. So maybe I'm going to eyeball it just a little bit. Something like this will be the circle on the inside. And you'll notice that because it's a circle, lines that come out of here at 90 degrees, which may or may not be these exact lines that I drew earlier, are all going to be equal in length because they are radii. So the incenter for an acute triangle looks like that. For an obtuse triangle, and again, thinking about this a little bit, we're going to find an incenter, and an incenter is the center of a circle that's inside a triangle. So the incenter should be inside the obtuse triangle as well, because otherwise we wouldn't have an incenter. So I'm going to find the angle bisectors of all these angles, and I do that by measuring. So the angle measure here looks to be about, I don't know, maybe 110, 115 degrees, 105, I should say. I'm trying to do math in my head when I can just read the number. 105 degrees. So if we cut that in half, we're going to get 52.5 degrees, which is somewhere over here-ish. So I'm going to draw a line between there and there. And there's my angle bisector. It cuts this guy in half, so this and this are equal angles. I'll do that for this angle down here. Let's do it like this maybe. So it looks like the angle there is about 35. If we cut that in half, we're going to get 17. Sorry, not 17. We're going to get 17 and a half. 17 and a half. So ish, somewhere around there. And if I draw the line here, it should cut this into two equal pieces, which is an angle bisector. Same thing with that last angle up here. So if I put my protractor on there and I check this angle, it looks to be about, I don't know, 47 degrees. So we're going to have 23.5 for halfway, so that's about here. So if I cut those angles, that angle into two pieces, I've got another angle bisector, and the intersection of those angle bisectors is the incenter, which is the center of a circle inside this triangle. So if I were to draw that circle, it would look something like this maybe. It's not a bad circle. And if wherever these lines coming out of here hit at a 90-degree angle, those lines that hit the side at a 90-degree angle will all be equal because they are radii. For a right triangle, same idea holds. That one's 90 degrees, so I know that half of that is going to be 45. So if I put my protractor here and I look for 45 degrees, it's about right there. And that should bisect my angle into two equal parts. So there's a 45 degree, there's a 45 degree. If I do it for my other angles, this one right here looks like it's about, I don't know, maybe 60 degrees, so half of that's going to be 30. So from here to here, appears that that line right here is 30 degrees off of that vertex. That's kind of neat. And then if I do this last angle here, I can find that this measure is also about 30. So if I cut that in half, I get 15, which is about here. So I draw a line between those two dots, and that'll cut that into two 15-degree angles, bisecting it. So we have our three bisectors, all intersecting at a central point right here, and that'll be the incenter of our triangle. So it will be the center of a circle, which I'm going to try to draw, that fits inside the triangle, and it is tangent to each of these edges. So it hits these sides at one point exactly. And the point that it hits it at will be 90 degrees. So from here to here, 90, and from here to here, 90. So that's the incenter of a triangle. It's at the intersection of the angle bisectors. It is always on the inside because it is the center of a circle inside the triangle. Inside, in. So that's our video on incenters. We'll have more on that later with some examples.